Hey everybody, this is Jim of Animateducated, and welcome to a tribute episode to Bill Matthews, Animation Educator. Bill Matthews recently passed away January 24th of 2022, and he was 94 years old, and he lived a pretty good life, I'd say. He was started his animation career back in 1959 on Sleeping Beauty at Walt Disney's. And then about 3 years later, he left the studio and he was an assistant effects animator at the time. And then he went off to join the Jet Propulsion Laboratory NASA had set up in Pasadena, California, for the motion picture unit. And he became the one-man animation department. I've got some of these from 1962 to 1966, and it's basically educational films about the time when they were just surveying the moon and looking at Venus and looking at Mars and things like that. And Bill actually animated the rockets and some of the, imagery. And I'm going to show you one of the films at the end of this presentation. And then that went on for like 10 years. And then around 1969, he joined Sheridan College up in Canada, where he worked in the animation department and made that place well known to the world and gave it international recognition. And then in 1979, I'm seeing a pattern here. It's like every 10 years, something happened. But he returned to Southern California, where he worked as an animator at Hanna-Barbera and Filmation. And he taught classes at night at CSUN in animation graphics. And then in about 1987, that's when Walt Disney they invited him to return to the studio to set up to recruit artists, new talent, to train that new talent, because they were working on getting the studio in Florida set up, and they needed more talent and they needed more people to work on more films. And so anyway, and then officially he retired from Disney in 1997. However, he didn't stay in retirement very long, because in 2000, he went to work back to teaching students in animation at Woodbury University. And that's where I met Bill. I got to teach. He was finishing up teaching, and he decided he didn't want to do the animation principles class anymore. And he was thinking about retiring for good. And he did, and I got to meet him, and we talked a lot, and that's where I met him. He also, like I said, he worked at Disney, and a lot of the people he worked with know him and are grateful for having him, got them in the industry at Disney. And he also made some friends with some of the directors there. They actually put some of his likeness in several films. So this one is from Little Mermaid. It's at the very end here. And in the crowd scene there's a kind of a chubby little fish with a very happy smile. That is supposed to be Bill as a fish. He was also in Oliver and Company. If you look at this one here, it's a very quick shot, but it's supposed to be him wrestling the other guy. So he's not doing too good there. This looks like him a lot. I mean, he's the kind of large gentleman on screen right. And yeah, so that's Bill Matthews right there. And that's pretty good. And of course, there's this one here This is from Hunchback of Notre Dame, and it's in the crowd scene, and it's supposed to be this one right here where this guy jumps into the beer right here. And let me just go through this frame by frame so you can see this a little bit better. Here he comes. Here he is. This is Bill, and he's going down into a jump. He's squashing there, and now he's going up, and he's at the arc, and he's coming down and landing into beer, which is drunk by a bunch of guys down at the other side of the barrel right there. So these are like 4 different like little things that he had on a DVD that said Bill's appearances kind of. Anyway, so now I'm going to show you a jet propulsion educational film that was produced by NASA and the Jet Propulsion Laboratory in Pasadena, where Bill actually worked. He was kind of the person responsible for, like I said, for kind of animating and illustrating those educational films showing rockets taking off, satellites opening up, and trying to simplify, what was going on using animation. And he also got a nice credit at the end of the film, which is pretty good, because mostly government stuff, they just, they would just say this is from the Jet Propulsion Laboratory, and that was it. And this was nice because they actually credited him as doing some animation.
In the earliest years of space exploration, man's first answers to the questions he asked were limited by the simplicity of his tools, the spacecraft, and the scientific instruments they carried. Gradually, however, as both man and his machines grew more competent and increasingly sophisticated, he began to delve into larger questions concerning our solar system. To do so, he needed to first examine the planets nearest to us, Mars and Venus. The planet Mars has been particularly intriguing. It is close enough to Earth for powerful telescopes to define dark areas on its surface that grow darker each spring, to watch polar caps form and then apparently melt, to see straight line markings that looked like canals, and watch dust storms sweep over the planet. But all these things we could see from Earth raised a host of questions we could not answer. Venus is covered by perpetual clouds, a solid barrier to telescopes, and our information about this planet has been scanty and contradictory. There has been, however, considerable scientific speculation on the nature and characteristics of the planet based on what evidence we had. Some thought that the landscape was punctuated by miles-high mountain peaks. Others, influenced by the dense cloud cover, believed it to be a soggy, swampy place. Or perhaps completely covered by an ocean of water, or even oil. Some, believing the clouds to be dust rather than moisture, pictured a dusty, arid desert. In the late 1950s, observations of Venus by radio telescopes on Earth showed it to be a strong source of radio waves. Some scientists interpreted this to mean an extremely high temperature on Venus. Others disagreed. Information about the planet remained sketchy and uncertain. To provide our first close look at Venus and at Mars, to answer some of these questions became a mission for Mariner. A new spacecraft for a new assignment. Mariner's spacecraft began to carry out the assignment at Venus in 1962 and at Mars in 1965, successfully probing both of our near neighbors in space. This motion picture is concerned with the return to Venus in 1967. But first, let's take a look at the beginning of the Mariner program. The first Venus opportunity for which the United States was ready with the required launch vehicles and spacecraft came in the summer of 1962. To perform our first planetary exploration, the proven Atlas booster was chosen and coupled with the equally proven Agena second stage. This combination had already demonstrated its space worthiness in the Ranger probes of the moon. In developing the Mariner for planetary probes, the Jet Propulsion Laboratory, assigned the task by the National Aeronautics and Space Administration, used much of the Ranger technology. There were new demands, however, requiring changes. Rather than communication over a distance of 240,000 miles, as was the case with Ranger, the Mariner, on its trip to Venus, would have to send signals from as far away as 36 million miles. There was also a new problem of reliability, since the spacecraft would have to function for months in space, as compared with a few days for a moon mission. Additionally, the spacecraft on its journey to Venus would be approaching closer to the sun, intensifying the critical problems of temperature control and protection from solar radiation. But the problems were solved as the Mariner spacecraft took shape and was successfully tested in laboratory simulations of a flight through space. For the first Mariner, the objectives were threefold: the development of a new breed of spacecraft capable of operating at interplanetary distances, accomplishing the interplanetary flight, and gathering and returning scientific information. Mariner 2, launched in 1962, met the challenge and passed within 22,000 miles of Venus. One scientific theory confirmed: Venus was hot, approximately 800 degrees Fahrenheit at the surface. Mariner flew again in 1964, this time to Mars with an advanced version of the new interplanetary spacecraft. A spare spacecraft for that program remained in storage on Earth. In December 1965, official approval was given to prepare the existing Mariner spacecraft to take advantage of a June 1967 opportunity for another launching to Venus. The first order of business for the new program was the checkout of the existing Mariner spacecraft and a new task for spacecraft designers: modify the spacecraft to convert it from a Mars mission to a Venus mission. Modifications were accomplished on electronic subsystems, solar panels, directional antenna, and optical devices to detect Venus. New deployable sunshades were developed to protect against the sun's radiation. The basic mission of Mariner 67 would be to add to the knowledge of Venus, but the mission would also verify the idea of converting a complex spacecraft from a Mars mission to a Venus mission. Whereas Mariner 2 passed some 22,000 miles from Venus, our growing competence in space would allow targeting of Mariner 5 to skim by the planet at less than 3,000 miles. The mission included 7 experiments: to determine the density of the atmosphere, to measure the number of electrons in interplanetary space and in the ionosphere of Venus, measure atomic hydrogen and oxygen in the upper Venus atmosphere, measure magnetic fields, detect radiation levels both in space and at Venus, measure the solar wind and examine its interaction with Venus, and refine data on the mass of Venus and the Moon, as well as gather other astronomical data. Launch on June 14, 1967 was on schedule and accurate. On October 19, the spacecraft flew by Venus at a distance of 2,546 miles above the surface of the planet. The occultation experiment, in which the spacecraft passed behind the planet so that the atmosphere could be observed by its effect on the radio signal, determined that the atmosphere of Venus is extremely dense and composed primarily of carbon dioxide. The radio signal was bent away from Earth by this dense atmosphere at a height where the atmospheric pressure was about 7 times that of the Earth. However, comparison of this data with information from planetary radars on Earth and by ranging with Mariner 5 indicates that the pressure at the surface is about 75 to 100 times that of Earth's, equivalent to the pressure at an ocean depth of 2,550 feet. Calculations of the temperature at the surface at that pressure would be in a range of 800 to 900 degrees Fahrenheit, as Mariner 2 had reported, hot enough to melt lead and zinc. Mariner 5 data also contributed significantly to decreasing the uncertainty of the mass of the planet, and in addition, verified a precise value of the radius of the planet, previously determined by radar measurements from Earth. This latter determination was crucial, since the Russians announced results of their Venus 4 spacecraft, which reached the planet 1 day before the Mariner flyby, making measurements of the temperatures, pressure, and composition of the atmosphere, which in some cases were not compatible with Mariner measurements. However, analysis of the Russian data based on our knowledge of the radius of Venus showed that the Russian vehicle did not transmit data all the way to the surface of the planet, as was first believed. The mission also determined that the magnetic field of Venus is 1,000 times less than that of the Earth, and maybe even smaller. It charted the complex interaction between the planet and the solar wind that streams continuously outward from the sun. It found that no radiation belts comparable to the Van Allen belts around the Earth exist at Venus. The knowledge gained in the Mariner Venus flights has cleared up some of the uncertainties, revealing some of the basic facts about the planet. We need to know still more about temperatures and pressures, the composition of the atmosphere and of the clouds. We want to know why Venus is so different from the Earth, despite being approximately the same size. Why is it so hot? Why hasn't it cooled? By learning more about Venus, or Mars, or the other planets, we learn more about our Earth and the origin and evolution of our solar system. Much remains to be discovered, but future historians, discussing man's knowledge of the planets, will be able to say, Mariner, here was the beginning.
I hope you enjoyed that tribute to Bill Matthews. Now you know kind of who this person was and what they're responsible for. If you enjoyed this and you would like to see more and you want to become a subscriber, you can just push that button right there. And yeah, don't miss out. I have other videos on this channel. You can check out these two videos. They're pretty good. And hopefully you'll see you next time on Animated Educated.